For this lesson, we will continue to look at systems, but this time in context. So how can we solve contextual problems using systems? And how can we interpret the solutions? What do the solutions mean? Pause this video, read through these problems here, or this one problem, and try to solve the system. See if you can create a system of equations and then evaluate, solve them. Okay, coming back, the easiest thing to do is to actually draw an image of what we have. So it says we have a rectangular room. I'll draw a rectangular room. It says the perimeter of the rectangular room is 90 feet. So we know the distance around this room is 90 feet. We also know that the perimeter of a rectangular is 2 times the length plus 2 times the width. And let's go ahead and call the length x, and we'll call the width y. So now we can just use our equation. Well, we know that the perimeter is 90, so 90 is going to be equal to 2 times the length, which is x, plus 2 times the width, which is y. That gives us one equation. Now we need to use some additional information. It says that the length is twice the width. Therefore, that's the length, x, is equal to 2 times whatever the width is. So if the width was 3, the length would be 6. Now we have both of our equations, and we can go ahead and solve, as we did in the last lesson, using the most appropriate method. In this situation, we have x, which is completely isolated and on its own side. So let's use substitution. We'll take 90 plus 2, and we'll substitute in 2y in place of x. Now we can just simplify. And there should be an equal sign in here. When we simplify, we just distribute, combine like terms, divide, and we get 15. In fact, this is a contextual problem, so we need to identify what 15 means. 15 means feet, so our width is 15 feet. What is our length? Well, remember, our length is 2 times our width. So it's as simple as just plugging the 15 back in for y here. And we know that our length is 30 feet. So with this contextual problem, we have created a system of linear equations to model this situation, and then we have solved them and interpreted the solutions. Let's look at 2 more problems. Our next problem has to do with an amusement park. So pause the video and try to solve this problem on your own as well. Examining this scenario, Bill and Steve are off for the afternoon at an amusement park. The water slide and the gigantic Ferris wheel are their favorites. So every time they ride it, their tickets get stamped. At the end of the afternoon, these are the tickets that they have. Bill's ticket has 3 water slides and 3 Ferris wheels, and he paid a total of $17.70, whereas Steve has 2 water slides and 3 Ferris wheels and paid a total of $15.55. What we want to know is how much does it cost to ride the Ferris wheel, and how much does it cost to slide on the water slide? Well, if we look at our solution, we can let W be the cost of the water slide, that's what we want to know, and F be the cost of the Ferris wheel. We can set up 2 equations, one for Bill, and if we go back, one for Steve. Bill had 3 and 3, and Steve had 2 and 3. If you'll notice, 3 water slides, 3 Ferris wheels, 2 water slides, 3 Ferris wheels, for a total of what they spent. Once we have our system of equations, it's pretty easy to solve. So in order to solve this one, the easiest method would probably be elimination. We have 3f and 3f. the easiest thing would be to just multiply one of these equations by a negative in order to eliminate our f's. When we do that, the water slide costs $2.15 per slide. When we substitute that back in, and I substitute it into this bottom equation, we can solve and determine that the Ferris wheel costs $3.75 per ride. So hopefully you got that right. Let's look at our third and final example. Again, pause the video and try to solve this system on your own. A printing company has two kinds of printing presses. We have a Model A and a Model B. Model A can print 70 books while Model B can print 55 books. We know the company owns 14 total presses and they can print 905 books per day. So we want to determine how many of each type of press do they have. When you're working with contextual problems, always define what your variables mean. We want X to be the number of Model A presses and Y to be the number of Model B presses. Now let's think about what we have. The company owns 14 total presses, which means that if we take X, the number of A presses, plus Y, the number of B, we would have 14 total presses. There's one of our equations right there. Now, we know that Model A can print 70, so if we take 70 times however many Model A's we have, plus Model B can print 55, so plus 55 times however many Model B's we have, we are going to end up with a total of 905 books that we print per day. Now that we have our equations, how can we solve this? We can either do elimination and multiply through here by either negative 70 or negative 55, or we could do substitution. Since my variables are isolated, I'll probably elect to do substitution. I'm going to isolate Y by moving the X to the other side. Now I can take this part of my equation and substitute it in for Y in my other equation. Let's see what we get. Replacing the Y with 14 minus X, now I just need to distribute the 55 into the parentheses, which gives me 770 minus 55X. I'm ready now to combine like terms. 70 minus 55 is 15X. I'm going to move the 770 to the other side by subtracting it from the 905. So 905 minus 770, and I get 135. Finally, to solve for X, I can divide 135 by 15, and I get 9. But what does that 9 mean? Well, 9 is what X is, and X we said was the number of Model A's. So we have 9 Model A presses. And how do we determine how many B presses we have? Again, we can just substitute this back into one of our equations. The easiest one would be the top one. If we have 9 in place of Y, then we have X plus 9 equals 14. So let's go back actually and substitute it in correctly. We're substituting 9 in for X, so we would have 9 plus Y equals 14. If we subtract 9 from both sides, we get 5. And what is the 5? The 5 is your Model B's, so Model B presses. And that is the solution to this problem. Now that you have seen three samples of contextual problems, now you know how you can solve them using systems. You also understand how you can interpret the solutions, depending upon how you identify and describe the variables.